Good morning. My name is Daniel Doc Sewell, aka The Zealot, and this is the morning of DEADFACE. I'm going to try to record some videos before the DEADFACE competition starts, and these are going to be walkthroughs to go through the puzzles that I created this year. This is my second year as an admin with DEADFACE. I have been playing this competition, I believe, since 2016, back when it was called Hack the Arch. And then when it became Hacktober, I continued to play. And then last year, I decided to help Jason, who is a coworker of mine, in the development of the puzzles and such. Okay, now let's take a quick look at Two Dead Boys. This is a very spooky poem. And it says, good evening. This is a news flash from Quick News Network, or QNN. I'm crime news reporter Frank Visionaire. There's a clue right there. And it's a poem I remember from elementary school. It's scared the living daylights out of me. Ladies and gentlemen, skinny and stout, I'll tell you a tale I know nothing about. The admission is free, so pay at the door, and I'll pull out a chair and sit on the floor. One bright night, in the middle of the day, two dead boys got up to fight. The middle of the night, sorry. And I'll let you read the rest of it, but it's pretty spooky. But down here at the end, we have some text. And that looks like flag right there. You can see our curly braces. So what we have is some kind of substitution cipher, apparently. And the fact that we got the clue up here, Visionaire, gives us a hint this might be the Visionaire cipher. So let's just pop this over to just Google Visionaire cipher decoder, and it should be the first thing that comes up. This is a really excellent one, decode.fr. France, and Visionaire decoder, and we'll paste our text right there. And let's just get rid of alphabet. Knowing a plain text word, let's put flag in there, and let's do a decrypt and see what we get back. Sorry, I think we need the alphabet. And we also saw the dash, and we've already got flag, we got curly braces, so let's add there. Let's just try automatic decryption. And bam! With the keyword flag, that worked. I believe you can also come in here and say knowing the key length. Let's just try this real quick. Knowing the key length, and let's just try automatic decryption. Wow, that shouldn't have worked. Let's just click on decrypt. Yeah, there we go. So what I wanted to show, automatic decryption, it's really good at figuring it out. But you could also get it by getting the just one-upping the key until you get to 9, and then it'll come in with the solution right here. The solution to fake news is critical thinking, question everything. Okay, so that is Two Dead Boys. Okay, let's take a look at Ozymandias real quick. And you might remember this poem from school. About an arrogant king who built a statue to himself. It's in the desert. A traveler finds it. It's all wrecked, and there's nothing but, colossal wreck. I like that. Boundless and bare, the lone and level sand stretch far away. So it's a warning against arrogance and hubris. So let's copy this encoded part right there. We'll paste that into CyberChef, and we'll analyze this a little bit. We notice that we have all capital letters and only capital letters, but we do have a few numbers. We have 2, 3, and 4. So the 26 capital letters plus 4 digits would give us 30, and we have an equal sign. We might have a 5 in there somewhere. So I'm going to take a wild guess and say that this is from base 32, because 26 plus 9 characters. And when we do that, we get some valid encoded output. So here we have more characters, and we have uppercase and lowercase. We have numbers. I don't see any symbols, but if we add the uppercase and lowercase together, that's 26 and 26. Gives us 52. So I'm going to take a guess and say that we might have base 58, because I don't see a lot of like symbols or anything. So we're pretty close to 58. So let me just move that over. And we got two choices. We got Bitcoin and Ripple, interestingly. So it could be either one of those. But we have some encoded output. So this was a valid, this is probably the correct one of these two. So it's base 58. But now we have another base output. Let's just, it's going to probably depend on which one we're looking at here. They both kind of are the same. Actually, I did it again. I did, I don't want to, I want from base 58. Sorry, I did that a second time. Okay. So that doesn't look like it's right. Let's try one of the other ones and see if we get something that looks, I mean, that could be like some XOR, oops. There could be some XOR encoded output. But before we go for that, let's try the other one. Let's just try Ripple. Oh, and look, now we got something that looks very similar to base 64, but there's a semicolon and a pipe symbol. So I don't, those aren't part of base 64. So we have some additional symbols. Maybe that's actually base 85. And so base 85, this doesn't look good to us. Let's try some of the other outputs to see if there's something that looks good. We'll try IPv6. And lo and behold, we have some text there. My name is Ozymandias, dude of dudes. Check out my skills, you buff bros, and come unglued. So, behold my works, ye mighty, in despair was the original poem, I believe. But I decided to go with some more hacker speak here. So there's the flag. So if you got this far, congratulations. If you didn't, the key here is to look at the character set, inspect it, and look for, count the number of characters that are in it, and see if you can get close to one of these, and then just try different outputs. Like I said, I think there's also some kind of auto that can like try decoding for you. That might be of some assistance, but if not, just a simple inspection and then trying different things will work for you. So anyway, hope you enjoyed it. Okay, this one is a bit of a booger. We're going to be doing Serial Killer 01. In fact, it's so much of a booger I had to go back and fix it. So let's go ahead and take a quick look at it. Serial Killer 01. Merviel doesn't like spooky serials. He prefers something much more pedestrian, but thoroughly sugarful. Enter the answer as flag as here's the answer. Choose the Windows or Linux binary, whichever you're most comfortable analyzing. I don't think it's going to make much difference which one you do. I'm going to use Windows just because I'm here in Windows. I poked around a little bit. I think these are all both generated off the same Golang file. So they're going to just, if you're comfortable processing one over the other one, just pick the one you want. So I've already downloaded the binary here. It's this 052. So let's go ahead and run it. See how it behaves. So if we go DEADFACE REO52, what is the best but not spooky serial? Don't know. Sorry, it's not the correct serial. Okay, so let's pull this up in IDA. IDA is a great tool to use for these kind of things because you can get a graphical representation of what the code looks like. You'll get this error message. The import segment seems to be destroyed. Nah, it ain't. At least we don't care. Because we'll get enough information here in IDA to show us what we're looking at. So what we're going to do is we're going to let it spin here. as it imports. And it's going to go to this graph mode. You'll get this basically one box right here. So a whole bunch of imported functions, because remember, Go compiles down to a single binary. There's no DLLs. So what we're going to do is we're going to scroll all the way to the bottom of this list of functions until we see something that looks like something that may have been written by the author of this program. So down here, main is always a great place to start. Let's double click that. And here's our graphical path view over here. You can grab the box and drag it down, or you can scroll around over here. So we saw that the program is sending out some messages. They don't actually show up here, but highlighted in blue are the function calls. So you can kind of follow those along and look for those. You can look for like where the input is being entered right here at scan line. And then there's a slice of the array being taken. And then right here, a dead giveaway of what our hash function is. Okay, so this hash function is being called on something, and guessing from the format coming in, the fscan line right here. So it's reading something from the input, it's taking a slice of it, and then it's hashing it. So we come down a little bit lower to the path. It does a make slice. We have another slice byte to string. And then down here, you kind of follow the path where you think it's going to go. And down here with this runtime mem equals. So what we think is going to happen, at least I'm surmising from this, is that the password entered, the serial name entered by the user gets hashed with this hash algorithm, which we said was SHA-3-256. And then it's going to compare that to some stored hash. So that stored hash is what we want. So I'm going to put a breakpoint right there, and I'm going to hit F9 to go ahead and run the program. Yes, it's okay. And it's going to run, and it's going to say what is the best but not very spooky serial, and we'll just give it anything. Don't know. Okay. So right here, you can see this call to runtime mem equal, and then it's got two registers that is it's passing in as arguments, essentially. Okay. So what we want to do is we want to mouse over those and figure out what those are. And lo and behold, this actually looks easier than when I did it. If I move my mouse over EAX, I see a 40. If I move it over this one up here, I see this 518D. So I'm taking a good guess. Let's look at ECX. Same thing. Let's go ahead and take a look at that memory. So if I come over here, now I just got this weird thing where we're debugging a 32-bit binary with a 64-bit debugger. So it's giving us the names of the registries, but so you just need to substitute R for E. So instead of RAX and RC, or instead of ECX and EAX, you got RAX and ECX. So looking over here, we got a couple of registers. We got RAX and RBX are both have the value 40 in them. So a SHA-256 hash is going to be it's going to be 64 bytes. So that's going to be like, actually, it's going to be 32 bytes, but when printed out, it's going to be 64 characters. So these two strings that are being compared, I'm going to take a wild guess and say those are going to be 64 characters long, which tells me, hey, I'm probably in the right place here. Okay. So the ones being compared are going, let's go ahead and step in to this function. And then we see here that the two arguments are being passed to ESI and EDI. So let's just go step over those two. And then they're being compared. Now, they're being compared to see if they're exactly, I was going to say they're exactly the same memory address. So yeah, if you look at it, the one says here, debug 45 114.123.co, and the other one says unknown 100 F4 D5. So it's comparing the addresses to see if they're the same, and if they are, it's just going to jump out. Otherwise, it's going to come down here. But what I'm really interested in doing is grabbing these two memory addresses and looking at them. So let's go to the ESI register, and it's kind of weird how there's probably a better way to do this in IDA, but I'm just going to select that. I'm going to do a Control-C to copy it. I'm going to open up a view, subview, hex dump. I'm going to come in here, I'm going to hit go. I'm going to hit Control-V. I'm going to jump to that address. Okay, so it looks like there's two copies of the same thing, but right there, remember it said 40 for the what we surmised to be the length. So I'm going to say that that means this is 64 characters long, right? So this would be like a text representation of the hash. So I'm going to copy that. Actually, I'm going to copy that, and then I'm going to put that into a notepad real quick. And let's put this all on one line. So this is one of our hashes. So that was the first one. That one was from ESI, right? So let's look at EDI, and that's this unknown address. So that looks like the static data, if I had to guess. So I'm going to copy that, and let's go to that address. And so you see right here, hash, colon, aha. That's probably the hash we're looking for. I'm going to take a wild guess. And then it ends down here in another colon. So I'm going to go ahead and drag. Well, actually, let's just grab all of this like this, and then we'll paste it in correctly. Let's do a Control-C. Let's go here. Oh, didn't copy it. I want to grab everything between those two colons. Like I said, that is like static data. So that's probably the hash that we're really interested in. Once again, I can't seem to grab the whole thing here. I'll just Control-C. And then we'll go to Notepad++. We'll paste that in. And we'll get rid of the extraneous data, and then we'll put it all on one line. Oh, look. So there's actually, there's val2 and then hash. So this is actually two separate values embedded in here. So this first one was called hash. Okay. So the second one, I don't reckon that we're going to be interested in, or actually I'm going to tell you what that is. That's actually an encrypted flag, but we don't need that for right now. We'll just take this first one. So it's going to, that rest of it was cruft. The way Golang puts things in memory, they're not delineated with zeros at the end, so it's really hard sometimes to see where strings begin and end. And that's why I threw the colons on both sides and put the hash in front of it to make it easier for the player to identify. Okay, so this is my hash, 518, and it ends in 776E. So I'm going to copy that. And then I'm going to switch over, I'm going to SSH into another machine. And I'm going to go to my bin hashcat 6.2.1 directory. Let's do nano SHA 3 solve.txt. Okay. And then I'll do a quick history. Grep SHA-3, grep hashcat, and we can see a line right here that is solving. I did this before, so if you search the hashcat help files, you'll find out that SHA-174 or 17400 is the code for SHA-3 256. So let's do SHA-3. Yeah, we do have SHA-3 solve. And then let's copy this dictionary. Let's copy the rest of this garbage here. We need all this. I still haven't figured out why I need to back end ignore CUDA. Something with my driver is not right. Let's get rid of the old pop file and let's crack the password. And there's the password, Cocoa Puffs. Okay. So now let's see if we get that to work. And there's the flag. So the key takeaways here are, first of all, you have to have some kind of knowledge and experience with assembly language debugging. Second of all, when you first loaded up the binary, that list of functions on the side, going down to the main and tracing it through. And then you want to find the user input. Remember, the user input was this fscan. Actually, we're inside this compare function right now. So let me do a jump out. Okay, so here's the main function. We came down through here. We found this hash to tell us what hash function is being used. And then we look for a comparison with the user input. We went in there. We looked for the value that was probably going to be the hash that's being compared against. We found that, and I nicely delimited that for you with the hash and the colons, so it was easier to see. And then once you got inside there, you basically copy that, paste it into hashcat, and then you know the algorithm, throw it in a dictionary file at it, and crack it. Okay, so this is actually going to come in handy for a couple of the ransomware challenges. IDA is going to become a very useful tool because you're going to have to dig through and find some information. That malware is also written in Go. So this is like a kind of a little warm-up for the big ones with a ransomware that are going to be a little bit more challenging even than this one was. So I hope you enjoyed it, and see you over in the next one. Okay, so we're going to look at reverse engineering, serial killer 02. And this says, how well do you know the zealot? See if you can answer this trivia question. Enter the answer as flag is here. So we've downloaded the file. And if we go in and do some quick looking at it, let's run strings on it and see what we can come back with. See if there's anything interesting. And we have this big long string right there. Interesting. But what do we have here? We have what looks like a hash. Let's take that and see if we can crack that over on CrackStation real quick, just out of curiosity. And Count Chocula. Let's go back and throw that in as our answer. What is the zealot's favorite breakfast cereal? Count Chocula. I'm sorry, but although the zealot will eat almost any breakfast cereal, he eats it without milk, which a lot of people find truly disgusting. That is not his favorite cereal. Therefore, I cannot share the flag with you. Please try again. Okay. So now I'm going to go ahead and do a quick file. Figure out what that is. And it's a .NET assembly. So I'm going to use dnspy, and I think I've only got the 32-bit edition on here, so I can't debug it, but that's not a problem really. What we're going to do, did I paste that up here? I did not. What we're going to do is come in here and take a quick look at the code. We have this buffer. And then we have another buffer called second. And then when the user enters in their text, which is read from the command line or read from the prompt, we take the MD5 sum hash of that and we compare that to this array called second. Array.sequence equals second. Okay. So what I'm going to do is I'm just going to throw in a quick bit of code here that is going to, I stole from Stack Overflow. And we're going to come in here and I'm going to do an edit class. This is a great thing about .NET Spy. You can come in here and easily edit code, recompile it, and save it to a new binary and run it. So I'm going to paste this code in here. And I'm going to modify it just a little bit. So all I did was I just basically Googled for how do you print a hex string in C#. And we don't want to return this. We want to just go ahead and print it out. So let me just do that real quick. Console.writeLine. Say the hash of the password is. We'll just add that right there. And we need one more parenthesis right there. Okay, so now we can come down here and click compile. B8 does not exist in the current. It's one of the things that it said I needed to change. So we need this second. We need second right there, and we need second right there. Okay, now let's compile it. All right, and then we can do file, save module, and we'll give it a new name. We'll call it -new. Okay. All right, so now come over here and run this. Actually, sorry. Yeah, we can just put in anything here. We need to run the second, or to run the -new. The hash of the password is right there. Copy that. Go to crack station. Paste that in. I'm not a robot. Do they want the kid on the bike or just the bike? I never know. Crack the hash. Ah, peanut butter crunch, which is much, much better. Okay. Let's come back over here. Peanut butter crunch. The hash of the password is, that's correct. Congratulations, here's the flag. Peanut butter crunch for the win. Does zealot. And that's your flag. Okay. We're taking a quick look at Serial Killer 03. Now this one is, it's a little tricky. If you try to go in and deal with the assembly language source code, but as it turns out, you don't really need to. And what I was hoping for was that some people would go in and try to debug the assembly code and be looking at things in a memory dump and then go, oh man, look at that. So I've already downloaded the challenge file, and let's just take a quick look at it with hex dump. It's probably the easiest way to see it. And this took advantage of the fact that most of your programs that you're going to use for debugging or viewing memory shows you 16 bytes at a time. You could figure that out by going through the code and noticing that a buffer is incremented by 17 bytes, which would shift it basically one character over in the display. So what you have here is you have the flag being in memory diagonally. Okay, so shifting, adding 17 bytes to the offset of the F gives you the L, and then the A, the G, etc. And then you can see that the flag is Apple Jacks. I didn't actually try to analyze this one through the code. I did try to make it as obfuscated as possible, but there's quite a number of solves on it. So I wanted one that maybe some more junior level players could get could kind of stumble across with some elementary analysis, and that maybe might frustrate some more advanced users who would try to go through and debug the assembly. But there's quite a number of solves on this one, so that's good. So anyway, I hope you enjoyed it, and I'll see you at the next one. Let's do Serial Killer 04. So in Serial Killer 04, Belief 1203 has a favorite serial. Can you guess it? Enter the answer as the flag. So I have already downloaded, and we'll go ahead and run. What is Belief's favorite serial? How about Life? Oh my, I've forgotten it myself. This is so embarrassing. I guess you can't get the flag. I'm so sorry. Wait, maybe you can think of one good way to recover the flag. As I recall, it is obfuscated using a very common, very simple technique. But for the life of me, I can't remember what it was. Okay, so very simple, common technique should lead you hopefully towards XOR, and one hopefully should lead you towards a single character. All right. So I took a bit of a shortcut when I did this, solve, and I Googled around to find a program that can do a command line tool for XORing a data stream with a given key. That's this mstrand xcat. So I found this and tested it out, and it works pretty well. What I wanted to do was I wanted to just go in here and just, since we don't know where the flag is and it's going to be XOR data, it's going to be probably garbled. You're not going to be able to find it with strings, and you're probably not going to be able to pick it out of just random, instructions and bytes and things like that. However, we do know that one of the words that's going to appear in the output when we've correctly de-obfuscated the flag is going to be the word flag with a curly brace after it. So what if we just XORed the entire file with a byte and then did a grep to see if we can find that particular flag, the text we're looking for. So I wrote a quick little script here to kind of help out a little bit. And so let's just type that reo6.sh. And what that's going to do is it's going to go from 1 to 255, and it's going to turn J into the hex character that xcat requires. So you could pass in a character, a single character, or multiple characters, but they have to be in this 2-character hex string format, right? So what this next line is going to do is it's going to turn J into that format. So it's going to start with 1, go to 2, 3, 4, and it's going to actually stop 1 shy of max. So let's just change that real quick. REO6SH. Oh, I need to go over here and do that. Sorry, nano reo6.sh. And what we need to do is we need to come in here and do this as a less than or equal to. It doesn't matter unless it's like exactly 255, which it probably won't be, but we'll go ahead and change it just for kicks and grins. Okay. And so now I have reo6.sh. Let's go back and look at that again. So I've updated it to go from 1 to 255. It's going to turn that J character into that hex string format, and then it's going to do a cat dead face. It's going to pipe it to xcat.py, which I've downloaded and put in this directory. It's going to pass a -x parameter with this 2-character hex string. It's going to run strings on the output to find. So xcat is going to XOR it, and that would turn it into plain text if this is the correct code right here, the correct hex number that we're XORing every byte with. We're going to do a strings to just filter out all the regular binary garbage and just find the strings, and then we're going to grep for the word flag. Okay, so let's go ahead and run that and see what that looks like. I know that other people had different ways of doing this, but like I said, I got a little lazy, didn't want to write the code myself, so I went out and found xcat. Turned out it was a great way, and then this little bash script around it just kind of simplifies it a little bit instead of having to, either run through all of them yourself one by one or guess. And there we have it. The string comes back and we see flag life. He said, "Hey, Mikey." It was a silly TV commercial from the 70s that had these little boys trying to get their little brother to eat cereal, and they say he won't eat it. He hates everything. And then Mikey starts eating it, and he really likes it. So life is his favorite cereal, and so that's the flag. Okay, you never did figure out the cereal. I guess the cereal will be life, but this is the flag. Okay, I hope you enjoyed that one. Okay, on to my favorite challenge, the farm. This one is not a terribly difficult one, but it was a lot of work to put together, but it was a lot of fun. I really enjoyed this. I had a good time with my friends putting this together. And what this is a creepy video of recovered from one of the laptops of Lytton Lab's secret area in the boiler room of the old Lytton, Indiana school building. And I can tell you that is one creepy place to be, even when the whole place is populated. So the video starts in a simple visit to a farm. It takes a dark turn when the videographer visits an abandoned house in the woods at night with a mysterious companion. There's a strange figure appearing to convey a secret message. Recover the message and enter it as the flag. Enter the flag in all caps and pick whichever video you want to download. I'll just go ahead and grab the 480p. We don't need a big video for this. Okay. So the challenge also mentioned that you can jump ahead to 11:22. There's our creepy figure in the video. You can jump ahead to 11:22, but I really do wish you watched the whole thing because I put a lot of work into this, and I just wanted it to be like a Halloween fun, kind of atmospheric thing. That's what the point of this video was, really. The message is just kind of a side thing. But we're going to go ahead and jump ahead a little bit past our little creepy guy here and past some of this creepiness. And right around here, right around 14:14, let me double check here. I think this is it. Yeah, we should see the video. We should see the figure pop up here pretty quick. Actually, we can go back a few seconds. I think it's right at the top of the stairs. No, that's where the heavy breathing comes in. So in just a few seconds, it's going to get to the part where this figure gives you a message. So flag, open curly brace, listen. And close curly brace. Okay, so in case you didn't recognize it, that is Morse code being played at 25 words per minute. Okay, and if you just do a quick Google search on Morse code audio decoder, you just come up to one of these websites here like this. This is the one that I used. You can upload the file and it will decode it for you. So you have to kind of isolate it, or I don't know how it's going to perform with all that music in the background. It may or may not be able to do it. There's a few things you could do. You could slow the audio down and try to isolate it, and then look them up, the character by character or whatever. But there's just different ways you could do it. I would hope that we still have some ham radio operators out there that could do this all like, hey, I know exactly what that said. But the secret message was all caps. You enter the flag like this. You say flag, I will be avenged sevenfold. Just like that. Because that's what the message is playing. So I would show you the demo of the website for you, but I'm in a VM right now and I don't want to go through the process of tearing out the video. You can also actually go to just search on Morse code online, and I think that's probably the first one I did. So I will be avenged sevenfold. I don't think it was this website, but you can do that here. They actually have somewhere you can specify the speed, and that's how I got 25 words a minute. Right, so mine was a lot much faster than that. At 25 words a minute. This is probably 5 words a minute, which is used to be the score you had to get to become a ham radio operator. Now they've gotten completely rid of Morse code because the U.S. Navy got rid of it. They no longer use it. Fun fact. I still haven't boosted myself to the next level yet. Still on my list of things to do, along with buying another ham radio. So anyway, that was the farm. I hope you watch the whole video. I hope you have fun with it. I hope you can, maybe get around the family with some popcorn. It's not that good. It's obviously very amateurish, and I edited it on iMovie. I didn't have a lot of special effects or things like that, but it was a lot of fun to put that together. I really enjoyed it. So I hope you enjoy it too. When you get some leisure time, when you're not, worried about solving challenges, take a look at it. Have some fun with it. All right. Thanks a lot, and we'll see you. So I'm going to start with this challenge called, it's a reverse engineering challenge called Another Fine Product Brought to You By. And unfortunately, Jason's busy, hard at work right now. Syntax is hard at work bringing up the scoring server and the challenge server. So I just copied over the description so we can just take a look at it here. The description reads, quality is our #1 priority at MicroSquishy. We want to make sure that all our customers are satisfied with the software we deliver. Your job is to QA our latest offering to ensure that our beloved customers have the best experience with our product. If you happen to run into any glitches, please run them to ground. Unfortunately, we can't let you have the source code since our organization must maintain absolute secrecy to ensure that our competitors do not steal our top quality service offerings. Note, it's strongly recommended that you run this program in a virtual machine as it will trigger many antivirus warnings. It is harmless. That's because it's using a packer, a custom packer that a guy did put a tutorial up on the web, and apparently a lot of malware users are using that tutorial as well. So I've downloaded the program. Let's take a quick look at and see what it does. So if we run the program, we get this window. It says quality. Another fine quality product brought to you by guess who. So let's take a look at our menus here. File, exit, functionality, get assistance. Hello, looks like you're trying desperately to use the software you paid for. Please help me. Do you have any idea how blankety blank busy I am? Oh, well. Get assistance. I'm doing just fine. Go away. Sheesh. Sorry I asked. All right, let's go to help. About. MacroSquishy has encountered an unspecified error of unknown origin at address 0DEA7EA107, or DZELOT, which may or may not have corrupted your entire system and by extension probably your entire life. Please contact Microsoft Tech Support to obtain a new Windows license, a new computer, and a new life. Oh, well, let's retry. Ignore this window popping up. That's an artifact of the packing software. For a limited time, receive a discount on new MacroSquishy licenses, computer systems, and lives by using the following code. Yeah, forget that. Are you sure you're not interested? These offers don't come around every day, Fine then. Don't blame me when your computer stops working. It doesn't matter which button you click. It's going to do the same thing. The program's going to crash. Okay. So you're going to throw this program up in a debugger, and the one that I like to use is WinDebug Preview because it has a super awesome feature called time travel. So what I'm going to do is I'm going to pull open WinDebug, and what time travel lets you do is it lets you step forwards and backwards through a program. So it's great for when you get those really weird crashes that you don't really know what's going on. So let's do this. Let's launch executable advanced, supports time travel. And we're going to select the program we downloaded. And we're going to record with time travel. We're going to configure. Let's do configure and record. And it'll give you a directory. Okay. So let's go ahead and click on record. And we'll skip right over here to help. And we'll click through our menus, and it doesn't matter what you click on. It's going to do the same thing. Click on retry. and we should get a big kaboom right here. Yes. Okay. So then what you need to do is go ahead and click Go on the debugger. And when you click Go, the first thing that should catch your attention right there is DEADFACE. Okay. So that's the address that it's trying to execute. Right there, you can see the EIP is pointing right at DEADFACE. Okay. Which happens to be a legitimate hex address, but is not a legitimate program address to jump to. So apparently we jumped to this address and the program crashed. So let me go ahead and click Go again. And let's do that a couple times. And it's kind of stuck right there. So let's go ahead and click on Stop Debugging. All right. So now if we go here to File, we can go to, so under here under Documents, you see this, it populated it here under Recent. You can see it's got this .run file. That's the recording of the time travel. So what it did is it basically recorded every step you did to the program, every input, all that stuff. And so you can load that up just like you would load up an actual binary to debug. And now you'll notice that here under File, you've got this whole new set of things. You got step into and step out, but you've also got back, step out, back, step into, back, step over, back. So here we are at the last instruction of the program where we stop debugging, and let's do step over, back. We did it once, let's do it again. And here we are at this instruction here, while system service call, let's step over, back. We're at raise exception, let's step over, back. Let's do it again. Let's do it again. Let's do it again. Let's do it again. We actually want to do step out, back. Let's do that. And there, we are at our instruction. This is where we noticed when we ran the program, when we stepped, we saw the EIP is DEADFACE. So now this is the really cool part. We can do a step out, back one more time, and that'll take us to the exact line in the program where the problem occurred, right there. Okay. All right. So that program is, or this line of code right here, is our problematic line. Okay. So let's examine a little bit and see what's going on ahead of us, right? So right before we see this series of move in the, we have call EDI. Let's go up a little bit higher. So we have push EDI, and then we have this move, this address into EDI, and then we have this push 10, and then call EDI. So there's one parameter of 10, and it's calling a function. And then it has another function right here at ESI, and then it's passing these parameters, and then it calls ESI, and then it calls EDI, ESI, it calls EDI, ESI, and it does that 4 times. Okay, hopefully that sounds a little bit familiar to you, but just in case it doesn't, let's go ahead and step over, back, and let's step into call ESI and find out what that is. So we can now step into, and we'll see that's calling message box, right? Okay, so I'm going to step out, back, and then I'm going to step over, back a few times to find out what that EDI call is. So let's go in there, and then oops, we can just step forward again. So let's just step over, and let's step into the call EDI, and that's message beep. So you recall in the program we had a message beep, a dialogue, a message beep, a dialogue. We had that happen 4 times, right? Okay, so I think the easiest thing to do is going to be to set a breakpoint on, I mean, you could do message beep if you wanted, but it makes more sense. It makes more sense to put a breakpoint on the call message. Okay, so there's a couple of tricks to this now. Now that we know where we want to put our breakpoint, The debugger is a little finicky. As much as I like the time travel and stuff, there's just a couple of weirdnesses, and I don't know if it's the debugger or just the way Windows works or something. But what we're going to do here is we're going to go ahead and we're going to start the program, and then I'm going to go ahead and get the first dialog box popped up. And now we're going to run WinDebug preview. And we're going to attach to the process. And this time we are not going to turn on time travel. So we're going to attach to the process. And what that does is that makes sure that all of our symbols are resolved. So I'm going to put a breakpoint at user 32 exclamation point message box W, because that's where that's what pops up the dialog boxes, and the 4 dialog boxes before our crash. So I'm going to do that, and then I'm going to hit go. All right, so now we're debugging, and we come down here, and so what we want to do, this is our first dialog box. So that means we've got 3 more. So we want to abort or whatever, click whatever you want. And then this is inside the call to our second dialog box. So we're going to step out, and that's going to execute that one. So that's the second dialog box. Okay, now we're going to step over, and that's our beep. And then we're going to have our call to our third dialog box. And we're going to step out. And this is our call to our fourth dialog box. And then right here, we'd like to set a breakpoint right there. But here's what we're going to do. We're going to go ahead and do, a step over. Step over, that's the beep. And we're going to go ahead and call the next dialog box. And we're going to do a step out. Okay, and that's going to land us right on the instruction, the bad instruction. Okay, and if you don't believe me, we can just go over here and do a ds colon, and let's just put that address in here. Control C, Control P, and there's our dead face, and it's a call instruction into this bad address. So what we want to do is we want to advance the function pointer 6 bytes, so that it just goes to the next one. So you can do that. You can do that here in WinDebug with this command. You can do an R, which is going to I'm not sure what that stands for. That's for like writing to the registers. So we're going to do EIP equals, and we're going to reference EIP plus 6 bytes. And then we're going to just go ahead and do a go run, to go continue. Okay. So when we hit that, there, we have skipped past the crash, and we have this little dialog box. And it says, everything you need is in front of you, observe carefully. Well, XOR password is blank, and we have these bytes right there, right? So those look like, let's throw that in the cyber chef real quick. And oh gosh, ads. So I'm kind of not, I never remember where I'm doing here. So let's try from hex. And it attempts to convert a hex dump back into raw data. Yeah, that's what we want. Okay. So delimiter auto or space should give us the same thing. And now what we want to do is we want to do an XOR. And let's change the key to UTF-8. So that's what we're missing is our key. But what the program said was, everything you need is in front of you. Observe carefully. XOR passwords, colon, there's nothing. But right there, quality, the word quality, it says everything you need is in front of you, okay? And that means everything. So let's go ahead and try to use QUALI. Oh, look at that. The flag is appearing right before our eyes. See that? QUALITY. Quality. It looks to me like we're missing this at the end. So I think we have two alternatives. I want to make sure to hit up Jason right now to make sure that we double check this and make sure that that is that you can put the closing brace on there. But we're going to go ahead and do this. We're going to do that, and then we'll just enter that as a flag. I'll make sure that you can drop off the closing brace as an alternative. But there's your flag. So the key things were time travel was nice, but you know, if you can figure out how to put the breakpoint in, you know, right before the last message box, you're good to go too. So anyway, I hope you enjoyed this puzzle. It was a bit of a bear to put together, but it was a lot of fun. Had to go back and learn C for Windows programming, using the API directly instead of using, you know, C# or anything like that. But it was fun, and I hope you guys appreciated it. So anyway, on to the next one. Okay, things are getting exciting. More challenges are coming out, and there's a lot of competition, and a lot of people are toughing out a lot of these really hard challenges. So what I want to do is I want to jump into the RansomWAR. So let's go ahead and take a look at RansomWAR 1. The RansomWAR has begun. So basically, last year, Lucifer and the Zealot hit up Litton Labs, hit them with ransomware. So now their mercenary hacker, codenamed Dark Angel, is getting revenge, and he has launched ransomware against DEADFACE. So we have these files here that all go with ransomware 1, 2, 3, 4. And for the first challenge here, we're only going to need the encryptor. So I'll just go ahead and click that one to download it. So we have Dark Angel Crypt 03. I didn't mean to run it, actually. It's fine. No harm, no foul. All my files are encrypted now, but that's no big deal. Not really. It's not going to hurt your system. Let me see. The download file name was Dark Angel-Crypt 03. Okay, there we go. All right. So we need to get the hash. I'm just going to pop over to Linux because this is way easier. And we can just do, we're asking for, if you scroll all the way down to the bottom, obtain the SHA-512 hash and enter the flag as the first 8 digits, a colon, and the last 8 digits of the SHA hash in lowercase as follows. So there's an example right there. All right, so let's go ahead and get that. So let me get back to my window and do a SHA-512 sum on Dark Angel. And there's our hash. So let's just go ahead and copy that whole thing and go to Notepad, and we can just come down here and let's just count off 1, 2, 3, 4, 5, 6, 7, 8. Let's just put a colon right there before the 99. Let's count backwards. 1, 2, 3, 4, 5, 6, 7, 8. And let's put a colon right there. And let's just cut the rest of the stuff out in between. And there we have our hash. I'm going to take a double check, make sure that that's right. Give me just a moment. And that is ransomware 01. So our flag is D5241CBD and 681EBF44, and that's correct. Okay, so there's our first flag for ransomware. All right, so ransomware 02 or ransomware 2 is a bit trickier. It's indicators of your host. So it talks a little bit about indicators of compromise and network-based indicators of compromise. and we have to enter one of either the user agent string or one of the two URLs that the malware is hitting. So to do that, we are going to have to set up a proxy server. So I have installed Burp Suite Community Edition. So I'm going to pop that open. Now in Linux, this is a bit easier to do because you don't really have to worry about any kind of third-party programs. You just set up an environment variable, HTTPS_proxy, and set that to your proxy server. But I'm going to use a program called Proxifier, which I got off of the internet. I learned about this in one of my courses I was taking. It's free for like a month. So you can go in here and you can create a proxy server. And we have on 127.0.0.1.80.80 HTTPS. So you can just edit that and just create that with these settings. And then that's going to point at the burp server. Okay. Then what we want to do is go to Profile and let's see here, proxy servers. No, I apologize for this. I don't use this that much, but proxification rules, that's what it is, profile proxification rules. And I've added Dark Angel Crypt 03 to use the proxy, and everything else just goes direct. Okay, so we want to run the program from Windows, so I'm going to run it from PowerShell. Let's run that program. And there we go. We have a couple of hits. Now I want to go in here to filter hiding, and I want to go ahead and say show all, apply. There we go. So now we have two URLs, and we can see here that we have HTTPS sinister.darkangel.tech and darkangel gen da key.php, password equals this number and shift equals this. So one of the flags is all of this and all of this up to the question mark. And it can be either one of these. And then also we have a user agent string right here. So you could enter darkangel_deadface_cryptoware/o.3 with flag tags around it. And that would also suffice as the flag. So it's going to be flag, curly brace, https://sinister.darkangel/gen-da-key.php, close brace, or you can do this whole one here and use gen-da.file.php. Either one of those will, or any of those three will work for the flag. Okay, and that is RansomWAR 2. Okay, let's take a quick look at RansomWAR 3, hidden in plain text site. Based on our initial analysis, we're certain that some of the data being sent from the key server to the Dark Angel cryptoware is encrypted. We are certain that Dark Angel is hiding this encryption key in plain sight and in plain text. So we're going to be looking for a plain text password. So we'll go ahead and click on the Dark Angel encryptor, and then that's going to download our file here. So I'm going to load that up in IDA. And I already took one look at it, but we'll just load it back up again. Scroll down, look at our functions. We can see our main right here. We see a fetch key function. We see a decrypt key with RC4. So that's what we're going to be interested in, but we can take a quick look at fetch key because they said that downloading information from the server that says fetch, so it can infer that it's being fetched, or you can trace the program through and figure out what's going on. But effectively what's happening is that this is our main function, and we're generating a random string. And if you remember, if you looked at the burp suite, the one where we attach burp suite to the function, you saw that there's a parameter called PWD that's being uploaded. on the URL, along with this random integer, which is the shift factor. Those are being uploaded to the server. And so we come down through here, we should see where the network traffic is going. Come back up here a little bit. There's the fetch key that we're interested in. So let's go ahead and take a look at the fetch key function. So in the fetch key function, we see a new HTTP request with context. It's allowing a proxy, and it's allowing unsigned or bad certs so that the proxy will work. And that was me writing that so that you could attach the proxy to it. And then we come down here and we see our HTTP transport. We see our user agent string. Here's our do, where the call is actually being made. We have main fetch key function 2. We don't need to worry about that. We're going to come down here and look at hex decode. So that hex string that comes back from the server is decoded, and then it's passed to main decrypt key with RC4. So let's set a breakpoint right there, and let's run this. All right, and we're going to step in. So I'm going to click on step in, and we'll step over a few things here. We'll come down here, and we see this new cipher. So let's put our breakpoint right there, and then hit F9 to continue, and now we're on this function. So we have parameters being from the registers that are being passed into memory addresses before this function is being called. So we can go and inspect the registers and see what's in them. And so actually, after I did one of the other videos where I copied this address and pasted it down into a hex window, which you can do, you can also click this little button, this little arrow button. I don't like to navigate away from the graph once I'm into it, because sometimes IDA can't get back into it, but I'll go ahead and do it here. So we want to inspect EAX, ECX, and EDX because those values are being passed into this function here. So let's go ahead and check EDX, or EAX, sorry. And if we look here, we see this looks like a string. And if we hit A for ASCII, you'll see that the string is called math.cosine, and that's being passed in. And we said it was plain text. That's being passed into RC4. You know, we could look at the other thing and you know, match it up with the data being passed from the server. But we would see that the other one of these other strings here is going to be the string being decoded. But this is our plain text password right here, math.cosine. So you want to enter flag, open curly brace, math.cosine, close curly brace. So once again, the key takeaways here are: use that little navigation bar on the left-hand side to go find the function you're looking for. Go to main, trace through, focus on the function calls first. Find what you're looking for. In this case, the challenge mentioned encryption. So finding that RC4 encryption, stepping into it, and looking for where the encryption object is being placed. You could also look at the parameters being passed into the function for the password. But in any case, if you trace it in to where the encryption is about to start, you'll find this plain text password. So I hope you enjoyed it, and on to the next one. All right, we're going to take a look at the bonus, the first bonus, ransomware, or sorry, the second bonus, ransomware 4, OFFCON 3. The files encrypted by codename Dark Angels cryptoware are likely contain extremely valuable information regarding DEADFACE's operations and security posture. Analyze the artifacts and decrypt the DEADFACE files that were encrypted with a ransomware binary. Enter the flag like this. So we want to grab all these again. You may already have them, but it's a good idea to go ahead and just grab them again. So I'm going to download them. All right, and I'm going to save this image as, let's go ahead and make a directory called RansomWAR 4. And we'll put the image darkangel.jpg into RansomWAR 4. All right, and then I need to go to my downloads and grab those latest copies. The ones I just downloaded just now. Let's copy those into RansomWAR 4. Okay, so if you did the previous one where you found the plaintext password, what you will notice is that the data being downloaded from, let's go ahead and just pull this up in IDA real quick. You'll notice that the data being downloaded from the server is encrypted. So if we look at crypt 032, let's open that up. Actually, let's be careful here. Let's make sure we get that from the right directory. So let's go to RansomWAR 4 and crypt. Let's just take another look at that. The data that's being downloaded from the server is encrypted with an RC4 key that's hard-coded. And on the previous challenge, we saw that password was math.cosine, all lowercase. That's the password being used to decrypt the with RC4 the string that's being passed down from the server. Okay. And then that string is actually going to be used to decrypt the output files. There's going to be a little bit of a problem though, and that is that we don't have the original parameters that were passed up to generate this string. So let's just go back down here a little bit, and I'm going to look at fetch key, and we come down to all the way down to the encryption function. And if you experimented with this at all with your own files, you would figure out a way to decrypt your own files, but that's not going to help you decrypt the file that has been encrypted by another key. So you don't know what the upload parameters were. All you know is the download parameters, right? So you can figure out how this works and say, okay, for files that I've encrypted, when I ran it, I can decrypt it with the same if I were intercepting the traffic and I did the decode of the key, right? And in fact, you might figure out even that if you send the same parameters up, you'll always get the same key back, right? But that doesn't really help you with decrypting an actual files that have been encrypted with a different key that you don't know what it is, right? So you can't, unless you know the parameters that were used to generate the key, this isn't going to help you. You're not going to be able to decrypt the key that encrypted these files. So you're going to have to take a little bit of a different approach, okay? And the instructions specifically say analyze the artifacts, okay? So analyzing the artifacts. Let's go take a look at the artifacts. And if you noticed, let me make a brand new, let's see, we've already got a RansomWAR 4 directory. And let me copy darkangel.jpg to darkangel.jpg. Or let's call it orig.jpg. All right. And then I don't know if we can do this from, I don't think we can do that from PowerShell, but we can do that from WSL. Let's do a SHA-1 some darkangel JPEG. Okay, so we see this is our SHA right there, 6F D6. Okay, now that we saved off the file. We made a copy of it. Now let's do this. Let's run the ransomware. Oh, these are all artifacts of IDA right there. Let's run the ransomware real quick. I don't need IDA right now, so I'm going to go ahead and stop it. Don't save the database, and let's do another directory. Okay, those files are gone. All right, so here's Dark Angel, timestamp 1027. Let's run the ransomware again. And like I said, we don't care about whether we have any files to encrypt or whatever. If you wanted to, if you really wanted to, you could do something like echo blah, let's call it blah.dface. All right, and then let's run the ransomware. So Dark Angel crypt. Okay, so your files have been encrypted. If we do a dir, we'll see that our blah got turned into a .rtoqs file. Now let's do this. Let's come back over here and let's do a SHA-1SUM on darkangel.jpg again. Aha! So we noticed that the SHA-1SUM has changed. Let's go make another one. Let's just do echo blah2 and save it to blah2.dface. Let's run the ransomware again and do a dir. And let's come back over and do the SHA-1 again. Every time you run the ransomware, darkangel.jpg gets modified. All right. So you got to ask yourself, and if you look at that, let's go ahead and take a look at the image. You look at the image, it looks the same. So why in the world would the image be changing even though it looks the same? You know, you could do like a binary diff on the images or whatever if you really wanted to. But a file that keeps changing and being downloaded kind of suggests steganography, right? So there's actually, so if you don't know how to capture the flags, you'll know that, hey, you know, let's go out there and look for Steganography, JPEG, images. You know, you can look around for some tools that might be, you know, images and files, CTF resources. Come in here and look around a little bit. You're going to ultimately come to JPEG hide and seek. So you might ask yourself, well, hey, does that actually, is it actually JPEG hide? And if you run a tool called JPEG, or I want to say Steg detect, it's actually going to come back with a false negative. So I've tried that, and that's what it does. So if you do Steg hide crack, and you look around, there's different programs that'll actually do it. The one that I like to use is this Rick DeJager Steg Seek, world's fastest Steg hide cracker. And he actually has this in a Docker container that you can use. There's also this passwordless extraction, but that's not going to work because there's actually a password on this right now. So here's what I like to do. I like to use this Docker container and run it there. Let's go to 101. And we'll do a history grep. History grep Docker. And RockU is a real common file. So that's been used in several different challenges. So it's a good place to start. And we're going to run this container right here, 106. Okay, darkangel.jpg.out already exists. Overwrite it. And let's do a cat on darkangel.jpg.out. Spell it right. And here you will get a string that says passcode equals, and it gives you the string. Okay, so let's go ahead and give that a whirl on our files here. So let's run the decryptor. Dark Angel. Sorry, we want to decrypt. And it says to decrypt your files, enter the key as a 64-character string. So let's put that string right there and run it. And a message authentication failed. Okay, so this is a little gotcha. And I needed this. Okay, so here's a little gotcha. You need to make sure that you only have DEADFACE file, or you only have your you only have RTOQS files that were encrypted by the same key in the same directory. If you have any others that you've been testing, it's going to cause problems. And I might need to go back and change the challenge to mention that. I got to discuss that with syntax. But anyway, that's going to be a problem. You need to make sure you don't have any others that you are testing in the same directory. I'm going to go ahead and run this now with the key that I extracted. And we get a message, Dark Angel, I would have gotten away with it too if it hadn't been for you meddling script kiddies. I hope everyone recognizes the reference to Scooby-Doo there, which was our password from last year. So if we do a, let's go ahead and open up Notepad++ and take a look at those files. Let's go into RansomWAR 4 and look at our DEADFACE files. All right. So we got some interesting information here. Speculation that Bumpy Hassan is the inside leak. Some information about the Acolyte, who, if you watch The Farm, that's the girl that smashed me in the smashed the Zealot in the face with a shovel. Some information about her, and then finally some reference information about the assault and the video analysis of the video, and some stuff like that. And then here's the flag, and here flag. It's getting real now. So. But like I said, the one thing that you have to be careful of is you don't have files that were encrypted with different iterations or different upload passwords and keys in the same directory, or it will crash. So anyway, thanks for playing. I hope you enjoyed it. Okay, I apologize, but RansomWAR 5 is going to be a really short one. It's almost identical to RansomWAR 4. There's a couple of changes that require you to take all the skills you put together from all the ransomware challenges and use them together. Okay, so the first thing is the password is no longer math.cosine, it's math.arctangent. So that's what's used to decrypt the download. You would have to find that by once again going in and debugging the program just like you did for ransomware 3 to find math.cosine. Now it's math.arctangent. The second change is that the downloaded JPEG file, now instead of having the passcode, it has the encrypted passcode. Okay, so you have to decrypt it with the correct passphrase for this binary. So if we take that and we move it over to CyberChef, you see I've put it in up here. I've put math.arctangent, and I got this output. And then I use that output with the decryptor right here. And it says I would have gotten away with it too if it hadn't been for you meddling script kiddies. So we have our DEADFACE flash alert, which I really wanted somebody to find these because I put some storyline in them. I'm going to talk to Syntax about posting these up on Ghost Town. I'll probably throw them up in the channel too, just so you guys can appreciate them a little bit. But I'm going to put them up there, and I'm going to just kind of slowly scroll through here so you can pause this and read some of this if you want to. And then here's the flag. It's getting real now. Actually, that was the last flag. Here's this one. Okay, so this one's a flash alert about Turbo Technical's capability analysis. So this is basically a kudos to all you guys, because you guys are Turbo Technical, and how you came in there and tore DEADFACE apart last year. How DEADFACE has a mole in the FBI FBI's got one in DEADFACE. A little bit of just, kind of the politics behind all this stuff. A little dig at my naming for the team last year, the Bluesers Club, stuff like that. And then here's the flag, bad boy, what you gonna do when they come for you? So I wanted to just throw this up there really quickly. Like I said, it's almost the same as the other one. You just have to notice that it's the ENC password instead of password, and you have to decrypt it with RC4 yourself. So one more challenge, Gods of the Copybook headers, and I'll get that one knocked out here real quick, and then hopefully we'll get this video uploaded tonight. Thanks for watching. Okay, we're going to start. We're going to do Gods of the Copybook headings really quickly. This one was almost identical to a challenge from last year, but only 4 solves. I was kind of surprised. I think last year had a lot more. So I've downloaded the file. You can see the poem by Rudyard Kipling, my favorite poem, one of my favorites, and a strange line of very Far Eastern looking text right there. I believe it's Hindi or Sanskrit. I don't know. One of you guys can tell me. So we saved that off to a file. So I just did a save page as, saved it to downloads, come over and open it up in a text editor. And if we scroll through, we can basically see a bunch of zeros in between our bytes. That tells us that, oh, that's Unicode, 16-bit characters. If I scroll down to the bottom, instead of seeing these strange characters, I see the 09, which looks like a dot, and then the text character, right? So starting from right there, there's this 09, 09, 09 for the first byte. So I'm going to do a replace, go to hex values and replace all the 09s with 00s, so they turn into the same text characters, Unicode text characters, English basically. Okay, so now we have this text in English, and I'm going to save the file, and then I will open it in a text editor. And now we have the code we saw in the hex editor. And that looks like base something something. So let's just go to CyberChef, pop it in, and looking at the character base, we figure out, that's roughly 62 different characters. There's uppercase, lowercase, some numbers. We add that together, we come up with 62. We take the default alphabet, and our flag pops out. Flag, wisdom for the ages, that rhymes. All right, so I believe that's all the challenges. There's actually one more, and that is Spooky Uniwhack. And instead of walking through that one, I think I'll just post the Python code in my GitHub and put a link to it over in Discord, so you guys can take a look at that. If you have any questions, you want to hit me up on Discord, be happy to answer them. But now I need to prepare this video for upload to, I said, Odyssey. Haven't decided on YouTube just yet. I got to see how Odyssey goes. But hopefully we enjoyed putting the CTF together for you. It was a lot of work. We appreciated the fact that you guys all enjoyed it. And everybody have a good day and keep hacking.